Hello, welcome to Advanced Algebra 2. Here we're talking about, what do we got here? Oh, we got the third learning target. Woohoo! And today we're going to go back to the one remaining thing, which will soon lead to the two remaining interesting points about parabolas. But that means we need to remind ourselves on factoring, which doesn't have a formula, which makes it both extra awesome and incredibly frustrating, and the quadratic formula, which does have a formula, which makes it really intimidating, but in the end kind of disappointing. All right, but still awesome, absolutely still awesome. Let's get to work. Boom. Okay, here we've got an example. We got x squared plus 10x plus 12 equals 0. So to solve it by factoring, I just, let's see here, we got to do a couple things, right? We got to ka-choom with a couple parentheses, a couple x's. Let's see here, we got to multiply to 12 and add to 10. Okay, so we're multiplying to 12, so we got a 6 and a 2. But if you think about that for more than a second, you'll see that makes 8 for the middle term. That's not good enough. I need 10, so forget about those. Let's see here, for 12, 3 and 4. That makes 7 for the middle term. No good. Yeah, it's a disaster. It's not going to happen. Okay, quadratic formula. Here we are. I'm just rewriting the equation. X squared plus 10x plus 12 equals 0. And then I'm highlighting what's going on here. The quadratic formula has a's and b's and c's in it. You must remember, or at least notice higher up on the page. And so I'm reminding you that a is 1 because it's 1x squared. B is 10 because it's 10x. And c is 12 because the constant term is 12. All right, we're ready to rock and roll. It's the first one we've done together in this class, so I'm going to go ahead and write out the formula. X equals the opposite of b, plus or minus the square root b squared minus 4ac, all over 2a. Good times, man. That song is almost as good as Hats Off to Beavers. All right, so now we're going to plug our numbers in. X equals the opposite of 10, because it was negative b, plus or minus the square root of 10 squared. Let's see, minus 4, minus 1, minus 12. I'm sorry, I'm saying minus. Those are times. It's 2 times 1 in the denominator. All right. Go ahead and work our way through this. Let's see here. We got a 10 squared. That's 100. That's not terribly hard. 4 times 1 times 12 is 48. So it's all over that. The denominator is now just 2. So we're talking about negative 10 plus or minus the square root of, we got 52. The denominator is 2. Good times. Bad news, 52 is not a perfect square. So square root of 52 is not some sort of super uber pleasant number. So we'll go ahead and on the side think about 52. And remember that 52 is 2 times 2 times 13. That is what we call the prime factorization of 52, which is a delightful 7th grade topic. So let's not remember the name so much as remembering that we got to break it down. Look for pairs. Hey, we got a pair of 2's, so the 2's can come out. So it's really negative 10 plus or minus 2 times the square root of 13 over 2. What I'm saying is what's being written. It's probably easier to just look at what's being written, though, in this case. We got a pair of 2's, so 1 comes out of the square root. Okay, now we need to reduce because everything I see there is even. And you might say, no, not the 13. I'd be like, the 13's not there. That's a square root thing. Okay, so everything can be divided by 2. And pay attention, everything means every term. So the negative 10 reduces to negative 5. The 2 in front of 2 squared 13 reduces to 1. And the 2 in the denominator reduces to 1 also. Okay, and then we have that, but of course, nobody writes that when your denominator is 1. That's crazy talk. So it's negative 5 plus or minus the square root of 13. Now, if you left your answer as the line above my circled answer, that would be correct. I would just kind of feel sad for you that you thought that looked good, but it would still be correct. Okay, that's one example. Factoring did not work. Quadratic formula did. Woohoo! Let's move on. Oh, another one. So we've got a nice little quadratic equation here. So let's get started on our factoring. 3x squared minus 13x minus 10 equals 0. Okay. Yeah, factoring is factoring. Yeah, a couple parentheses. Now the good news, of course, is that it's still 3, so it's just 3x and x. Let's see here. So we got a plus 1 minus 10. If you think about the middle term, that makes negative 29. That's not it. Okay. Change the signs. This is different. Now it's positive 29. That's not it either. All right. Let's see here. 10 and negative 1. Oh my gosh, that's plus 10 minus 3. So we're talking about 7, I think. That's not it. Okay. Let's see here. I gave up on the 1s and 10s. There was actually one more option I hadn't even tried yet. Let's see here. 5 and 2. So we got plus 5 minus 6. That's minus 1. That's not it. 2 minus 5. That's plus 2 minus 15. Hey, that'll work. So, that's it. Let's see here. The only thing is, over here, I should have written, and I'm going to fix it right now, it should have said equals 0. That's not really the exciting part, because the exciting part is getting it to factor. Okay, so look, we got it to work. So we have two little equations. 3x plus 2 equals 0, or x minus 5 equals 0. Solve each of them. So 3x equals negative 2 and x equals negative 2/3. You should be bored by now about that. X equals 5. Okay, if you want to be cool like me, you should write an or in between and circle it all up, and boom! Bob's your uncle, you've got an answer. All right. Okay, quadratic formula. 3x squared minus 13x minus 10 equals 0. Good times. Let's see here. A equals 3, B equals negative 13, and C equals negative 10. A is for the leading coefficient, B is for the linear coefficient, C is for the constant. All right. X equals the opposite of B, plus or minus the square root of B squared minus 4AC, all over 2A. Throwing some numbers in, so we're talking about the opposite of the negative 13, plus or minus the square root of negative 13 squared minus 4 times 3 times negative 10, all over 2 times 3. Okay, that's just throwing the numbers in, but pay attention to what happens next. There are a couple key things I want to make sure that you're noticing, just kind of on how you line up numbers. Hopefully you have good habits, and if not, we need to work on fixing them. First of all, that makes positive 13, because it's the opposite of whatever B was. So the very beginning is actually positive 13. And then remember, when you squared negative 13, that should have ended up as positive 169. All right. 13 plus or minus the square root of 289 over 6. That's it. Good times. Square root of 289, good news, is 17. It's a nice number. So it's 13 plus or minus 17 over 6. Woohoo! So we got two options. We got 13 plus 17 over 6. And we got 13 minus 17 over 6. And so we got ourselves, let's see here, 30 over 6. And of course that's really just 5. And we got negative 4 over 6. And that's really negative 2/3. Hey! Those are the same answers over on the left. Yeah, because remember, factoring, when it works, will always give you the same answer as quadratic formula. It's just different process. Okay, example 3. So x squared plus 5x plus 7 equals 0. The numbers are nice and small. This should be less painful than the last example. You got x, you got x. Let's see here. 7. We need pairs that multiply to 7. 1 and 7. Nope. That's going to make 8 in the middle. Ooh, I know. Yeah. 7 and 1. No, that's still 8. Oh, goodness gracious. Okay, this is a disaster. Let's move on and do the quadratic formula. So x squared plus 5x plus 7 equals 0. And so a equals 1, b equals 5, c equals 7. All right, now, as Coach Boyer says, Hats Off to Beavers is the world's greatest song. I have found it oddly soothing to my daughters to sing to them when they can't go to sleep. True story. And the second greatest song can still have its words changed slightly. X equals -5 plus or minus the square root 5 squared minus 4 times 1 times 7 all over 2 times 1. It's not quite as good. Much like hats off to Mika or hats off to Asa is not as good as hats off to Beavers, but you can still sing to it. Okay. X equals -5 plus or minus the square root of 25 minus 28 all over 2. Yeah, it becomes less good as you start simplifying. Let's see here. -5 plus or minus square root -3 over 2. Yeah, so good. Except if you look more carefully, like that -3. Not really doing a -3. And that's the key. You're not really doing a square root of -3. So there's no real solution. Funny story. This is not actually the same thing as saying no solution. It means no real solution. We'll have to use our imagination later on. But for now, that's all for example 3. No answer for today. All right, example 4. So we got ourselves a 3x squared plus 13x plus 22 equals 0. Okay, so set it all up for factoring. Got 3x in one, x in the other. All right, 2. There's not a lot of options for 2. So we got +1, we got +2. Let's see here, that makes 7x for the middle term. That's not going to work. 2 and 1, sure. That makes 5x for the middle term. That's also not going to work. This is a disaster. Nope. Okay. Quadratic formula. 3x squared plus 13x plus 2 equals 0. A equals 3, B equals 13, C equals 2. Yeah, nothing exciting. X equals the opposite of 13, plus or minus the square root of 13 squared minus 4 times 3 times 2. All over 2 times 3. All right, where are we? X equals opposite of 13, plus or minus the square root of 169 minus 24, all over 6. Okay. -13 plus or minus the square root of 145 over 6. Okay. Gosh, if that was square root of 144, then we'd be having 12 and be happy. But it's not. It's the square root of 145. So let's see, go over here in prime factorization land. 145 is 5 times 29. There's no pairs there. So that's it. We're done. Okay, one more, and then a little chatty chat at the end. But here we have 5x squared minus 6 equals -7x. Okay, now, first of all, I'm just trying to fool you, and you're way too smart. You know immediately that this is all fun and games. You've got to make the thing equal to 0 first. So go ahead and move the 7x over to the other side. Since we're in advanced algebra 2, we don't need to show the plus 7x on each side, but you can if you like. You might just think it gives you good style points or makes the angels happy or whatever. That's okay too. Okay, so then for factoring, 5x squared plus 7x minus 6 equals 0. Just kind of writing it out. All right, so we got let's see here. We got a 5x and we got an x. Thank goodness 5 is prime at least. Otherwise we'd have other options to try in there. What a disaster that would be. Okay, so -6. Let's see, we got +6 minus 1. That makes a middle term of, let's go with a 6, 5, of positive 1. That's no good. I need it to be 7. -6 plus 1. Let's see here. That makes -1 for the middle term. That's no good either. That makes -29 for the middle term. Yeah, that's not it. That makes positive 29 for the middle term. Okay, I'm done playing games with 1s and 6s. What else? Oh yeah, 2s and 3s. Okay, so -15 plus -13. No. All right. 15 minus 2. That's positive 13. Yeah, no. Let's see, plus 3 minus 2, that's negative 10 plus a negative 7. Ooh, kind of the right number-ish, but not exactly. So just change the signs on them. Negative 3 plus 2. And we have plus 10 minus... Hey, positive 7. Winner, winner, factoring dinner. So 5x minus 3 equals 0, or x plus 2 equals 0. All right. Two little baby equations to solve. So 5x equals 3, so x equals 3/5. And x equals negative 2. Yeah, kind of annoying, but, you know, nothing gets square rooted, I guess. Hey, quadratic formula. 5x squared plus... Okay. Notice I'm writing down the version that's equal to 0, because the other stuff is just there to fool you. All right, a equals 5, b equals 7, c equals negative 6. Good times. X equals negative 7 plus or minus the square root of 7 squared minus 4 times 5 times negative 6, all over 2 times 5. So x equals negative 7 plus or minus the square root of 49 plus 120, all over 10. Negative 7 plus or minus the square root of 169 over 10. Good news, the square root of 169 is a nice number. So we're talking about negative 7 plus or minus 13 over 10. Now we can break that bad boy into two versions. One with a plus, one with a minus. And then for the plus one, that makes 6 over 10, which is 3/5. For the minus one, you get negative 20 over 10, which is negative 2. Boom! Hey, we've got the answers, and they match the factoring answers. All right, the goal by now is couplefold. First of all, you should know that factoring is an option. You should know that quadratic formula is an option. You should know that quadratic formula will always work, except for example 3 where it didn't, but you knew that it didn't work. You should know that factoring sometimes doesn't work and is sometimes a pain, although sometimes, like perhaps example 2, really pleasant. But quadratic formula will just always punch that through for you. So, good times. One last bit of business here. There's something called the discriminant. It's the part underneath the square root. So it's the b squared minus 4ac. There we go. And if you just calculate the discriminant, it can kind of give you a quick idea on how many solutions there are. It does not tell you what they are specifically. You have to do the whole quadratic formula for that. But it will tell you how many solutions there are. And I've got the cases listed for you. They're also in your textbook. So if the discriminant, b squared minus 4ac, if that's less than 0, then there's no real solutions. If it's equal to 0, there's one real solution. And if it's greater than 0, there's two real solutions. And just to go back over what we did just now, in example 3, that happened where there was no real solutions. We haven't had any that were equal to 0 during these notes, so not in these examples. And then the one where it was greater than 0, so there were two solutions, that was all the other examples. So 1, 2, 4, and 5. That's about it for the notes. There's the assignment, although, of course, I invite you to just wait and do it in class. This has been a little bit longer, certainly a bit more tedious, no doubt about that. But please let me know if you have any questions, and thank you for watching.